Good morning to all. I am Dr.Dhondiba, Assistant Professor of Chemistry, Government First Grade College, KR from Bangalore. Today I am going to discuss about the seventh session of chemistry and third session of gases state, which belongs to first semester BSc, affiliated to Bangalore North University. In this session, I have to discuss about most probable velocity, average velocity, and root mean square velocity. Now, main objectives of these sessions are definition of most probable velocity, average velocity, and root mean square velocity. Then expressions of most probable velocity, average velocity, and root mean square velocity. Then also you have to know about what are the relationship between most probable velocity, average velocity, and root mean square velocity. This these we have to discuss one by one in this session. Now, after completion of this session, you come to know about the meaning of most probable velocity, average velocity, and root mean square velocity. And also you have to know about the expressions of most probable velocity, average velocity, and root mean square velocity. And also what are the relationship between root mean square velocity, average velocity, and that is the most probable velocity you have to know. This after you will know after this completion of this session. Before going to discuss this session, you have already know about Maxwell-Boltzmann velocity distribution equation, then meaning of arithmetic mean, how to determine that is arithmetic mean of a particular numbers, that you have to determine, you have already know. Again, you have already known about how to determine that is square root of particular number. These you have already known before discuss this session. Now coming to that is now here the main that is the main concept of these sessions are here. The velocities are there. There are three types of the velocities are there. First one is most probable velocity. Second one is average velocity. Third one is root mean square velocity. Now we have to discuss one by one. The first one goes to that is the most probable velocity. It is represented as CMP. Now how it is defined as the CMP? The velocity possessed by the maximum number of molecules in the gas or in the sample, and which is corresponding to maxima or maximum on the Maxwell velocity distribution curve is called most probable velocity. We can also be defined as, suppose consider a gas molecule containing that is 100 molecules. Out of 100 molecules, the most molecules having a same velocity, and some molecules having a very less velocities, and another some molecules having a very least velocity or high velocity. Some molecules having a very high velocity, some molecules having a very less velocity, and some molecules having a same velocity. Therefore we say that is a velocity, the number of molecules, means out of 100 molecules, suppose 50 or 60 molecules possesses the same type of the velocities, and these are the corresponding to maxima in a Maxwell velocity distribution curve is called that is the most probable velocity. It is represented as CMP. Now coming to that is a derivation of most probable velocity. Now here derivation of expression for most probable velocity or speed from Maxwell-Boltzmann equation. This question is important for examination point. It will be asked for 4 marks to derive an expression for most probable speed of a molecule from Maxwell-Boltzmann equation. That you have to, that will be appear in the exam. Okay. Therefore, how to derive this expression? For that we require that is the Maxwell-Boltzmann equation. Therefore, consider or from Maxwell-Boltzmann equation. Maxwell-Boltzmann equation can be written as dnc divided by n equal to 4 pi into m divided by 2 pi rt to the power of 3 by 2 into e to the power of minus mc square divided by 2rt into c square dc. Now this equation is called as a Maxwell-Boltzmann equation. Now here this is the dnc divided by no, that is a probability actually here, and it is a transfer, that is a dc, no, dc is nothing but change in velocity, and c is nothing but velocity of the molecule. So c is nothing but dc is nothing but change in velocity, and other are nothing but that is a temperature, and m is nothing but mass of the gas. Okay, molecular mass of the gas. Therefore transfer dc to left side, we will get that is a 1 divided by n into dnc divided by dc. This is equal to 4 pi into m divided by 2 pi rt whole to the power of 3 by 2 into e to the power of minus mc square divided by 2rt into c square. This is the equation we will get here. Therefore this means 1 divided by n into dnc divided by dc is called as a molecular probability. Molecular probability. How many probable molecules are there? That will be a given. Therefore now molecular probability that can be undergo a differentiation. Therefore differentiating this equation with respect to c. Here this is considered as a y. This is the considered as a constant because there is no c term will be there, and here there are two functions here, e to the power of minus c square divided by 2rt, it contains c will be there, therefore it is a variable, and a c square will be another variable. Therefore these are the two functions are there. Therefore this is the constant, these are the two functions. This is the called as a first function, e to the power of minus mc square divided by 2rt is the first function, and c square is the another function. Okay, therefore differentiating this equation means I can write dy by dx, no, like that. D of this is the y means 1 divided by n into dnc divided by dc divided by dc equal to this is the constant means that is 4 pi into m divided by 2 pi rt whole to the power of 3 by 2. It is taken as it is. It is then open the bracket, square bracket. Now here two functions are there. Differentiation of two functions means first function keep as it is. Therefore I consider as that is e to the power of minus mc square divided by rt is nothing but first function, and c square is the second function. Therefore first function as it is means e to the power of minus mc square divided by 2rt, it is keep constant as it is. Then take the differentiation of second means the differentiation of c square means that is it became a 2c. Then put there is a plus sign. Then keep that is second function as it is means c square as it is into differentiation of that is the first function. Differentiation of first function means e to the power of minus mc square divided by 2rt. Because of e function will be there, therefore it is the differentiation as it is e to the power of minus mc square divided by 2rt into take the differentiation of this term here minus m divided by 2rt as a constant value, and that is c square, it is take differentiation 2c. Therefore it after that is taking I can write that is minus 2mc divided by 2rt. Now here make this equation simplification, this two get cancelled. Then again what are the you have to see what are the common factors. Here c will be there, here c square will be there. Therefore in this function it is c is the common factor. Another e to the power of minus mc square divided by 2rt and minus here e to the power of minus mc square divided by 2rt is the same. Therefore it is a common factor that should be take outside. Therefore I can write this is equal to 4 pi into m divided by 2 pi rt to the power of 3 by 2 into c e to the power of minus mc square divided by 2rt as a common factor. Remaining 2 will be there, that is 2 minus of mc square divided by rt. It is close the bracket, another close the bracket. This equation will be get. Now we have to apply that is condition at the peak of the curve or at the tip of the curve. Any peak means at the maximum value. at particular there is a peak, the velocity of the particular molecules will be 0. Therefore, since at the peak of any curve, that the change in velocity will be almost all 0. Therefore, the probable velocity, the change in probable velocity, it is taken as a 0 at a peak level. At peak means hip of the curve or tip of the curve, that will be taken as a 0. Therefore, in this equation, this term becomes a 0. That is a d of 1 by n into d and c divided by dc whole divided by dc equal to 0. Substitute this value in this equation, and that equation, therefore we can write that is a therefore 4 pi m divided by 2 pi rt whole to the power of 3 by 2 into that is c is the replaced by, that is cmp now, because it is most probable velocity. We are taken that is at its peak level, so it is a 0, no? Therefore we say that is a cmp into e to the power of minus m cmp square divided by 2 rt into 2 minus of m cmp square divided by rt, close the bracket, another close the bracket, equal to 0. Therefore transfer this value, because this is the multiply value, that side it goes, that is became a 0. This also transfer to that side, it became a 0. Therefore now it became, because it is not equal to 0, because 2 will be there, no? Therefore this term will be a 0, because here 3 factors will be there. This is the x, y and z. Therefore x is equal to 0. Then you take that is the y is equal to 0. Then this is the z is equal to 0, means therefore we can write that is a 2 minus cmp square divided by rt equal to 0. Therefore we can write that is cmp square equal to 2rt by m after transferring these terms to right side. Therefore we can write that is a cmp is equal to square root of 2rt divided by 1 m after taking that is a square root on both side, or transferring this square to that side. And this expression is called that is a expression of most probable velocity of a molecules, gas molecules. And this equation is used for calculation of that is a most probable velocity. Now coming to that is second type of the velocity, average velocity, and it is represented as c bar. C bar is nothing but average velocity, or we also can be represented as C average, AV. It is a representing. Now how it is determined? Define arithmetic mean of various velocities. Arithmetic mean of various velocities of gaseous molecules is called that is average velocity. Therefore, how it is determined? Arithmetic mean of various velocities of gaseous molecules is called average velocity. For that, no, we can let the total number of molecules be n in a particular gas, and the C1, C2, C3 dash dash Cn be the individual velocities of molecules 1, 2, 3, etc. That is n respectively. Then average velocity is given by C average or C bar equal to C1 plus C2 plus C3 dash 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 plus Cn whole divided by total number of molecules. We will get that is a average velocity. But from Maxwell equation, it has been established that the average velocity is given by the expression average velocity or C bar is equal to square root of 8RT divided by pi m. 8RT divided by pi m. Substituting the values of r, t, pi and m in this expression, the average velocity can be calculated. This is about that is a average velocity. Now third one is root mean square velocity. That is, it is also called as a CRMS. Now this can be defined as the square root of mean of squares of velocities of gaseous molecules is called root mean square velocity. How it is determined? Square root of mean of squares of velocities of gaseous molecules is called root mean square velocity. For that, let the total number of molecules be the n, and C1, C2, C3 dash dash Cn be the velocities of molecules 1, 2, 3, 4 dash dash n respectively. Then root mean square velocity is given by CRMS square root of C1 square plus C2 square plus C3 square dash 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 Cn square divided by total number of molecules n. From the kinetic theory of gas equation, it has been established that root mean square velocity is given by expression CRMS equal to square root of 3RT divided by m. This equation directly came from, that is the kinetic theory, and it not necessary to derivation. It is just you have to take directly. By substituting the values of r, t and m, the root mean square velocity can be calculated. Now last coming to that is a relationship between root mean square velocity, average velocity and most probable velocity. At a given temperature, means the velocity of a gas molecules depends on temperature. Therefore, at any given temperature, it can be seen that root mean square velocity is greater than average velocity, which is greater than, that is the most probable velocity. So that we can write in the ratio form root mean square velocity proportional to average velocity is proportional to CMP. This is equal to the value of, that is a formula for calculating, that is the CRMS, that will be written as first term square root of 3RT divided by m is proportional to, that is average velocity formula square root of 8RT divided by pi m, and is proportional to the formula for calculating CMP, that is square root of 2RT divided by m. Now divide this equation by root of 3RT divided by m. Then we will get, that is a CRMS is proportional to C average is proportional to CMP. This is equal to, we are dividing this root of 3RT divided by m whole divided by root 3RT divided by m is proportional to root RT 8RT divided by pi m whole divided by square root of 3RT divided by m proportional to root 2RT divided by m whole divided by square root of 3RT divided by m. Now this term will be get cancelled, therefore it will become 1. After that is a cross multiplication, RT get cancelled, m get cancelled, therefore square root of 8 divided by 3 pi will be there, and after calculation that is after simplifying you will get, that is a value. Here again RT get cancelled, m get cancelled, therefore 2 by 3 will be a square root of 2 by 3. Then you are removing, that is a square root, we will get that is value root mean square velocity is proportional to average velocity is proportional to that is the most probable velocity equal to 1 is to 0.9213 is proportional to 0.8165. Now by using this relation we can calculate the relationship between any two velocity. Now first one is we can calculate the average velocity with respect to root mean square velocity, means average velocity can be written as 0.9213 into square, that is a root mean square velocity, or root mean square velocity equal to, we can multiply by 1.085 into average velocity. This is the one relation. Suppose we know that is a RMS velocity, from that we can calculate that is the most probable velocity. So most probable velocity is equal to 0.8165 into that is CRMS, or if we know that is a CMP, then we can calculate CRMS by multiplying 1.22 into CMP. Or suppose another relation, suppose we know that CMP, then from that we can calculate that is a average velocity C bar equal to 1.128 into CMP, or CMP equal to, we can calculate, that is 0.8865 into C average. These are the relation, these are the formulas for calculating the average velocities. Average velocities, most probable velocity, and root mean square velocity, uh, one by one, by knowing particular velocity. Now so far we have discussed in this session the most probable velocity, average velocity, root mean square velocity, their expressions. Again, that is what are the relationship between uh, each other, that we have so far discussed. Now therefore I will ask some questions. Please you have to answer, you have to observe carefully, and you have to answer one by one. The first question goes to, that is the velocity possessed by the maximum number of molecules in the gas and corresponds to the maxima on the Maxwell velocity distribution curve is called. Four options will be there: average velocity, root mean square velocity, most probable velocity, and D option is none of these. Just you have to say please uh, check choose the correct option for this question. I will give just 10 seconds for you people. You have to select correct answer. The correct option of this problem is C option, that is the most probable velocity, because this is the definition of most probable velocity will be there. Therefore, the C option is the right option of, that is the question number 1. Then question number 2. Arithmetic mean of various velocities of gaseous molecules is called. First option goes to average velocity. Second one is root mean square velocity. Third one is C1 is most probable velocity, and D is none of these. Correct the pick the correct option. I will give just 10 seconds for you people. Now correct option of this question is uh, A option, that is average velocity. Average velocity is nothing but definition, arithmetic mean of various velocities of gaseous molecule is called average velocity. Therefore A option is the right option for this question. Then third question, square root of mean of squares of various velocities of gaseous molecules is called. The first option goes to average velocity, second option goes to root mean square velocity, C option goes to, that is third option goes to most probable velocity, and D option goes to none of these. Just I will give 10 seconds for you people, you choose correct option. Now right option of this question is B option, root mean square velocity. Root mean square velocity is the definition is nothing but square root of mean of squares of various velocities of gas molecules is called root mean square velocity. Therefore, the B option is the right option for this question. The fourth one is expression for most probable velocity of a gaseous molecules is given by. First option, square root of 3 RT divided by m. B option, square root of 8 RT divided by pi m. And C option is square root of 2 RT divided by m. And D option is none of these. Choose correct option. I will give just 10 seconds for you people. the C option is the correct option of this question, because the square root of 2RT by m, this expression is called, that is the expression for most probable velocity of a gas molecules. Therefore, C option is the right option. Then fifth question is expression for root mean square velocity of gaseous molecules is given by, first A option is square root of 3RT divided by m, B option is square root of 8RT divided by pi m, and C option is square root of 2RT divided by m, and D option is none of these. I will give just 10 seconds for you people. You can choose the correct option. The A option is the right option for this question. Therefore, the square root of 3RT divided by m is the expression for root mean square velocity of a molecules. Then sixth question is expression for average velocity of gaseous molecules is given by, first option goes to square root of 3RT divided by m, square root of 8RT divided by pi m, and square root of 2RT divided by m, and D option is none of these. Select correct option. Just I will give 10 seconds for you people. The B option is the right option for this question, because the square root of 8RT divided by pi m is the expression for average velocity of gaseous molecules, which is obtained from Maxwell-Boltzmann equation, and this is the correct option for this question. Therefore, for preparation of this session, I have referred these books, and this is the session. Thank you.